The world is awash in polluted air these days. Over 90% of us breathe it in every day. And as we have just heard, at least one of those pollutants robs us of some happiness. But with this bad news comes good news from the world of technology, as a team of Belgian researchers has developed a way to clean the air of some pollutants and convert them into simple hydrogen, using sunlight, special membranes, and nanoparticles. Hydrogen is a clean industrial chemical and, when burned, simply makes water. Sammy Verbruggen is a researcher from the University of Antwerp and part of the team that achieved this breakthrough, so we called him up to ask him how it works. Sammy Verbruggen, welcome to Living on Earth.
Thanks, Steve.
So tell me, how was this project conceived and who were the primary players in developing the study?
Well, actually, it's in two parts. So for the one part, our group in Antwerp has been working a lot on trying to do air purification using light. So we're developing special type of nanomaterials called photocatalysts. So nanomaterials that are activated by light, and in that way can convert air pollution in less toxic compounds. Now, on the other hand, there's the group at Leuven University, where Professor Johan Martens is working a lot on these photoelectrochemical cells. So he's actually working on these membranes and devices to try to convert water into hydrogen gas. And now in this step, we actually combine both processes together and try to use not water, but actually polluted air to convert it to hydrogen.
Explain for us just how this air purifying process works now.
Well, at first instance, you have the nanomaterial. It's activated by light, so you get charges inside of this semiconductor. Well, the next step is that these charges, they will attack some of the molecules that are adsorbed on the surface of the material, and that way you get very active oxygen species. You actually do an oxidation. So you oxidize organic molecules until, when they're completely mineralized, you end up with CO2. The hydrogen is something very specific. During these degradation reactions, you also get some protons coming out of the molecules. And these protons, they go through a membrane to the other side of the device, where another catalyst is present, and it will reduce the protons to hydrogen gas.
So what kind of pollutants can you filter with this device? And how clean is the air once it's done purifying it?
Well, at first instance, we have been looking at quite simple, small organic molecules. So our study primarily focuses on methanol, also in part to acetic acid and some ethanol, so all fairly small organic molecules. But still, some of these molecules can be quite hazardous to your health as well. For instance, formaldehyde is a very known indoor air pollutant which can cause you headaches. Acetaldehyde, it's the stuff in your brain that gives you a hangover. So obviously, they're not very healthy to you. So attacking these small molecules is quite useful as well. Ideally, everything that passes through the light side of the device gets oxidized to CO2. So give you a very straightforward example. Let's say we start from methane. So it's one carbon atom and 4 hydrogen atoms. In the most ideal case, it will end up as one CO2 molecule at one side and 2 hydrogen gas molecules at the other side. So that's stoichiometrically a very clean reaction. Obviously, efficiencies aren't 100% as the device is proposed right now, but that's something we are working on.
So, Sammy, we all hear about, this could be a great technology. How optimistic are you about the possible implementation of what you have put together? I mean, how difficult is it going to be to increase this to a scale that would be useful?
It will certainly be challenging. There's no denying that. I think we're facing 2 major issues that have to be resolved right now to get it to a breakthrough level. One thing is to increase the efficiency. These materials that we are using, they're actually activated by UV light right now. So if you have a look at the solar spectrum, the contribution of UV light is at most 5% of the total spectrum. Now, what we are trying on one hand is to modify these materials so that they can also use visible light. So in that way, we could extend our activity range to say 40, even 50% of the solar spectrum. Another thing would be trying to upscale this design, because in the first test that we have been doing now, we are working on a membrane with an active area of about 1 square centimeter, which is obviously not much. If you compare this to other solar-driven technologies like solar panels you can put up on your roof of your house, we're looking at square meters of active area. So the upscaling towards larger membrane sizes will be the other challenge.
So talk to me about the amount of sunlight required to facilitate the process. You say it has to be ultraviolet. It has to be in the ultraviolet spectrum right now. How useful would this be, do you think, where, it can be cloudier?
Absolutely. And there's also the geographic position of the country you would like to use it in. I live in Belgium. It's very optimistic to think you can drive everything on solar energy because it's indeed quite cloudy here most of the time. Whereas if you look at real pilot scales of photocatalytic processes, they're mostly centered around the Mediterranean here in Europe, or even in Japan. There's also some applications of that. So that's indeed a very good point. That's why we are also working on modifying these materials towards visible light, because that's always around.
So, how big a deal does this have to become, Sammy, to really make a significant dent on urban air quality? I mean, how possible would it be for your devices to clean up the smoggy air of, say, Paris or Beijing or Mumbai? There are a lot of places with a lot of dirty air.
Yeah, that's true. But I think it's a little utopia to think we can clean up an entire city. That's maybe a little far-fetched. But I think it might come in handy in conjunction with a very specific industrial process, for instance. I can imagine if you're in the paint industry or something in textiles, that there are some processes involving a lot of organic solvents. So I can imagine they have very loaded waste streams, loaded with organic molecules, and they will have to meet some environmental quota. They can't just put it in the air, or I hope they don't just put it in the air. So if they could use a technology like this one, they can hit two flies at once. They could purify the air on one hand, but on the other hand, they can recover part of the energy that is stored in this polluted air as hydrogen gas, for instance.
Sammy Verbruggen is a guest professor and postdoctoral fellow studying photocatalysis for environmental and energy applications at the University of Antwerp in Belgium. Thanks so much, Sammy, for taking the time with us today.
You're welcome.